use of partial fraction to find the inverse Laplace transform. But if the quantity is f bar of s is very big quantity, then using partial fractions we can split into small quantities, small parts. Then after that we will apply the inverse Laplace transform. Then we get the answer very easily. Now how to solve the problems? We don't have any technique here. Directly I am writing. You know very well how to consider the partial fractions. Now let me solve the problems. Some problems on partial fraction. L inverse of s minus 2 by s square plus 5s plus 6. This is the first bit. Second bit is L inverse of 1 by s into s plus 1 s plus 2. Then now let me solve the first bit. The inside L inverse of f bar of s is very big quantity. First of all, that quantity can be reduced into small parts. S minus 2 by s square plus 5s plus 6. Then this can be written as s minus 2. The denominator part split the middle term. Then according to splitting the middle term, then the factors s plus 2 into s plus 3. This can be written as, these are normal factors according to partial fraction rule, a by s plus 2 plus b by s plus 3. Now you calculate capital A and capital B. For that purpose what I will do, this side is s minus 2, then a into s plus 3 plus b into s plus 2. The denominator part we can cancel it after taking the LCM. I am not writing that part. Then if you want to calculate EAB values, means put s equal to minus 2. S equal to minus 2 means the b is 0. Then minus 2 is minus 4 equal to a equal to minus 4. Then put s equal to minus 3 and a value is 0, minus 5 equal to minus b and b equal to 5. Means we know very well how to calculate, how to solve the partial fraction problems, and according to partial fraction technique I got the values of capital A and capital B. A equal to minus 4, b equal to 5. Substituting these values of A and B in above equation, then s minus 2 by s square plus 5s plus 6, that equal to 4 by s plus 2 plus 5 by s plus 3. Then now you apply L inverse. L inverse of s minus 2 by s square plus 5s plus 6, that equal to L inverse of minus 4 by, this is minus 4, minus 4 by s plus 2 plus 5 by s plus 3. Then minus 4 is outside. L inverse of 1 by s plus 2 plus 5 into L inverse of 1 by s plus 3. Minus 4 into e power minus 2t plus 5 into e power minus 3t. Like this we can solve the problem. Here I have substituted minus 4. That a value is minus 4. Please concentrate on that part. Now like this we can solve the problems. If the quantity is more, then by using partial fractions we can solve the inverse Laplace transform problems. In that second bit, what is f bar of s? 1 by s into s plus 1 s plus 2. Then resolve into partial fractions. A by s plus b by s plus 1 c by s plus 2. Again according to partial fraction rule, 1 equal to a into s plus 1 s plus 2 plus b into s plus 2 plus c into s plus 1. Then s is according to LCM rule a into these two factors, s plus 1 into s plus 2. Then b by s plus 1 is there except s plus 1. The remaining factors you have to write here. C by s plus 2 means except s plus 2, you write the remaining two factors. Then this rule we have applied, means this type of concept already we have applied in partial fractions, you know very well. Then for the values of A, B, C, substitute s equal to 0. When you are substituting s equal to 0, B and C values are zeros. Then in above equation, 1 equal to 2a, when you are substituting s equal to 0. Then a equal to 1 by 2. If s equal to minus 1, then a and c are zeros, then definitely we will get b value, 1 equal to minus b, then that implies b equal to minus 1. If s equal to minus 2, then first two parts are zeros, then automatically we'll get the c value. S equal to minus 2, therefore 1 equal to 2c, c equal to 1 by 2. Now you substitute ABC values in that fraction part, in that quantity. Therefore 1 by s into s plus 1, s plus 2 equal to 1 by 2s, a value is 1 by 2, that's why I am writing here 1 by 2s, minus 1 by s plus 1, b value is minus 1, plus 1 by 2s plus 2, c value is 1 by 2. Now you apply the inverse Laplace transform. L inverse of 1 by s into s plus 1, s plus 2. Then 1 by 2 into L inverse of 1 by s. We cannot apply L inverse of this big quantity. That big quantity we have reduced into small quantities. That's why we are applying here. 1 by 2 into L inverse of 1 by s minus L inverse of 1 by s plus 1 plus 1 by 2 into L inverse of 1 by s plus 2. Therefore, according to basic formulas, half into 1, L inverse of 1 by s is 1. Next, 1 by s plus 1 is e power minus t. Half into L inverse of 1 by s plus 2 means e power minus 2t. On simplification, 1 by 2 is common. 1 minus 2 into e power minus t plus e power minus 2t. This can be written as half into 1 minus e power minus t whole square. In the similarly, another problem, L inverse of s square by s plus 1 into s plus 2 s plus 3. Here the denominator has non-repeated linear factors, means non-repeated. S square by, first of all you consider f bar of s equal to s square by s plus 1 into s plus 2 into s plus 3. This can be written as a by s plus 1, b by s plus 2 plus c by s plus 3. According to partial fraction rule, s square equal to a into s plus 2 s plus 3 plus b into s plus 1 s plus 3 plus c into s plus 1 s plus 2. LCM rule, except s plus 1, then write the remaining two factors. The b by s plus 2 is available, except s plus 2, then b into the remaining two factors, c by s plus 3 is there, then except s plus 3, c into the remaining two factors. This is partial fraction technique. Then for calculating ABC values, putting s equal to minus 1, minus 2 and minus 3 in the above equation, then 1 equal to a into minus 1 plus 2 into minus 1 plus 3, the remaining all are zeros, then we are getting a equal to 1 by 2. Next, s equal to, when you are substituting minus 2, it becomes 4 equal to b into minus 2 plus 1 into minus 2 plus 3, the remaining two factors are zeros, that implies b equal to minus 4. And when you are substituting s equal to minus 3, it becomes 9 equal to c into minus 3 plus 1 into minus 3 plus 2, the remaining factors are zeros, therefore c equal to 9 by 2. A, B, C values I got it, s square by s plus 1, s plus 2, s plus 3, that equal to 1 by 2s plus 1 minus 4 by s plus 2 plus 9 by 2 into s plus 3. Then now you apply L inverse Laplace transform. L inverse of s square by s plus 1 into s plus 2 into s plus 3, that equal to 1 by 2 into L inverse of 1 by s plus 1 minus 4 into L inverse of 1 by s plus 2 plus 9 by 2 into L inverse of 1 by s plus 3. Then according to basic formulas, half e power minus t for the first part, minus 4 into e power minus 2t plus 9 by 2 into e power minus 3t. Like this, we can apply partial fractions while calculating the inverse Laplace transform of f bar of s. We have more partial fractions techniques are there, then you see the more problems, right? This is the simple technique.